A resistor is a fundamental electronic component that limits current flow within a circuit. It is characterized by its resistance value measured in ohms. Resistors can be used to protect sensitive components, divide voltages, and set biasing levels. They come in various forms, including fixed and variable types, and are vital in controlling electrical signals to ensure circuits function correctly and safely. A resistor is an electronic component that limits or regulates the flow of electric current in a circuit. It is designed to resist the flow of electrical current, creating a voltage drop across itself. The amount of resistance is measured in ohms, O, and its primary function is to control the current that passes through it according to Ohm's law, which states V, I, X, AR, where V is the voltage in volts, I is the current in amperes, R is the resistance in ohms. Key points about resistors. Function. Resistors limit the current that flows through a circuit, protect other components, and help set the appropriate voltage for other parts of the circuit. Types of resistors. Fixed resistors. Their resistance value does not change, e.g., carbon metal oxide resistors. Variable resistors, resistance can be adjusted, e.g., potentiometers, rheostats. Applications. Resistors are used in many applications, such as controlling current in a circuit, dividing voltage, protecting sensitive components, and shaping signals. Power dissipation. Resistors also convert electrical energy into heat as the current flows through them. The power dissipated by a resistor is given by the formula PURs I2 XR or PURs V2 R, where P is the power in watts. Example: if a 5V voltage source is connected to a 1 kΩ resistor, according to Ohm's law, the current that flows through the resistor will be I, V, R, 5V, 1000 R, 0.005 A, 5 MAOA. In summary, a resistor is an essential component that controls electrical current in a circuit, ensuring that other components receive the correct amount of power. A resistor is a passive electrical component used to resist or limit the flow of electric current in a circuit. It plays a crucial role in controlling and regulating the current and voltage within an electrical or electronic system. Basic definition. A resistor is designed to provide a specific amount of resistance, which is measured in ohms, O. The resistance it offers determines how much current will flow through it when a voltage is applied. According to Ohm's law, where V is the voltage across the resistor, in volts. I is the current through the resistor in amperes, R is the resistance in ohms. Key features of a resistor. Resistance. This is the property of the resistor that opposes the flow of electric current. It is measured in ohms, RO. Power dissipation. When current flows through a resistor, electrical energy is converted into heat. The amount of heat produced is related to the power dissipated, which is given by the formula P, Pi2R, or P, V2R. Tolerance. This indicates how much the actual resistance of a resistor can vary from its rated value. For example, a resistor with a tolerance of plus 5% can have a resistance value within 5% higher or lower than its nominal value. Types of resistors. Fixed resistors. These resistors have a set resistance value and cannot be changed. Examples include carbon film resistors, metal, film resistors, wire wound resistors. Variable resistors. These resistors have an adjustable resistance value. Examples include potentiometers, used for adjusting voltage in a circuit, e.g., volume control in a radio. Rheostats, used for adjusting current in a circuit. Specialty resistors. Thermistors. Resistors whose resistance changes significantly with temperature. Light-dependent resistors, LDRs. Resistors whose resistance changes with the amount of light falling on them. Applications. Current limiting. Resistors are often used to limit the current flowing through sensitive components. Voltage division. They can be used in combination with other resistors to divide the voltage in a circuit. Heat regulation. Some devices use resistors to dissipate heat safely. Signal processing. In circuits like filters, amplifiers, and oscillators, resistors are used to control the flow of signals. Example: if you have a 10V power supply and a resistor of 5 Ω in series with a circuit, the current flowing through the resistor would be This means 2 amperes of current will flow through the resistor. In summary, resistors are fundamental components used to control the flow of electric current in a circuit, protect sensitive components, and adjust voltage and current levels.